Ready to go live was the question. You are live now. Great.
Great.
Hello, everyone. Hello to, let's say, the last official session of the Meet the Experts. This time we are connected in three different locations. And let me maybe first of all welcome our dear guests. Um, this is Steffi, as you can see her at the moment on the main screen. And Steffi gratefully is located in the production facilities, the solution facilities of Gasmet. And on in her background, we are going to see some equipment. Yeah, great, thanks. We will see a little bit more in detail. And good morning, Steffi, first of all.
Good morning. Nice to be here.
It's a pleasure in December time, and I'm very happy to have you on board, and I'm very excited
Thank
about
you.
this session because as we wrote also in the comments, we are going to talk about very special components, gas components today, and I
Yeah,
think
exactly.
this is enriching our webinar session to have more information, not about the standard gases, so to say, but even
hmm
talking about dioxin, mercury in this session. Yeah, at the
Yeah.
same time, allow me to say hello and good morning also to Jyrki. Jyrki, you are responsible that we are together here.
Oh yeah, for sure. That's right. That's right. Yeah. Good morning. Morning from Finland. From
Good morning.
snowy Finland. It's very cold outside as well.
Oh yeah. I think that's actually the perfect handover to someone who only knows snow from pretty far away. But before we move to Jemsen from Singapore, Jyrki, yeah, let me thank you. You reached out. I think it's been some time, and I'm very happy we all made this happen. And like I said, I'm quite excited about this session. Okay,
Absolutely. Very nice to be here.
yeah, great. So, Jemsen, what is your temperature?
Mine was is on the equator, 365 days, and we have three seasons. It's hot, hotter, and hottest.
Uh, I must say this time we can compete a little bit with Finland, not exactly, but there's regions in Germany where we will get some snow today also.
Nice.
Yeah, but I mean, I think the conditions in Finland are different to the conditions in Singapore for sure, but obviously also in Germany. Yeah, great to have you here, Jemsen. And like I said, I'm very excited. The last official session for this year, and I think we can learn a lot about, like I said, different components, and especially also, the sample handling specialities about that. Okay, so maybe we also should. I always forget about that, James. We also should welcome the audience and ask them maybe to leave a comment. As you can see, we are now Singapore, Finland, Germany. So it would be just great and nice if you could leave us a small comment. How are you doing? Where are you currently from? And where are you located at the moment? And
Yeah.
at the same time, we have special topics today. So if there's any special questions, feel free to ask them. Feel free to leave a comment. So at the end, we hope to have enough time to answer all the questions, or to at least make sure that we connect you with the right experts. Okay, Jemsen, if you could be so kind and share the presentation we prepared for this session, I think that will be great. So, is it coming, James? Oh yeah, there we go.
Yeah.
I can see it. Very good. Yeah. So, oh, this is already the final, the last slide, Jameson. If you can go to the first one, I think
Sorry.
that's good. No, no problem. It's like I said, it's the end of the year session.
It's celebration mode.
Yeah. Okay. Yeah. Meet the experts in December 2021. If you go to the next slide, Jameson, that has been the overview slide. If you want to remember, we had different big names there in our overview session. But today we are together with Gasmet, and I think that's going to be pretty special. Yeah, this is a warm invitation to our Christmas party. I'm very aware, or we are very aware, that we have participants from all over, from all over the world. I think I can say that. And we know that even in your cultures, Christmas is probably not celebrated. But maybe you take your time. It's going to be next week, 8 o'clock CET, so same timing like we always have. And I think it's just going to be a nice come together with the family of process analytics. And it would be great if you can join. Maybe just leave a short comment just to say hello. And you see some faces you saw this year. And I'm also preparing a little bit kind of a best of and outtakes from the sessions we had so far this year. So I would be happy to see you there. Okay, at the same time, and this is something we improved, sometimes we get the message that there are issues in joining our sessions on LinkedIn Live. And here is the good message, because I can see we have also some viewers at the same time on YouTube Live. And this is something we are going to improve. So you will have access to all the Meet the Experts videos and recordings on our YouTube channel. They are also available on LinkedIn, but they will always be available on YouTube. And I'm pretty sure, as our dear guests, the company Gasmet is pretty active in social media as well, that after this session, we will share the session, and I'm pretty sure it will also be available on their communication channels. So this is the message. Nothing will be lost. Okay, good. So let's have a look what is on our plate today, on our agenda today. So we thought it's a very good opportunity to show or to give an overview of, let's say, the standard gas sampling components as an essential part of gas analysis systems, and to give an overview, because we often talk here about the different solutions, the variety of solutions we have for probes, heated line coolers, for example. And I think then it's pretty nice to see, to measure these special components. Also very special solutions and equipment are needed. And then we are going to get a small introduction to the company Gasmet and the background, and really hands-on. And therefore, I'm very thankful, Steffi and Jyrki, for preparing this, that we can really get some inside views, some live views of your solution. Okay. And then, at the end, we will hopefully have some time about to have the Q&A session. Good. Jemson, as you are more expert than I am, maybe you can give us a short overview of the let's say standard components of a gas sampling system.
Yeah, so thank you very much. It's not that I am more familiar, it's just that I am more time spent in the field. to carry out, a practical analytical solution. So this is an overview. I think many people would like to say that what is the most important component in this extractive cold dry system. All right. So of course, like ourselves, AGT, the first component would be the sample probe, which is the only product or only component that really exposed to the process. All right. So it has to get it right, because this is the only object that really intruded into the process. So get it up, and more importantly is the dew point. All right, the dew point, not just because of filtering of particles itself. And then after the probe, and now the gas has been siphoned, there is a downstream, there is a sample pump, right? It goes through the heated sample line, and it brings the sample gas above the acid dew point. So the correct word should be acid dew point. All right, so it depends on the gas matrix that you have in the process. Make sure that it is above the acid dew point. All right, so having said that, what is so important? The whole extractive systems, we have to avoid any condensation before the gas reaching the gas cooler. So talking about the gas cooler, one of the important things is the heart of the whole sampling system. Many people are asking why the gas cooler is, it is so expensive. Well, it is so expensive. It is because it is able to cushion a very, very hot sample, all right, in the shortest time with the thermodynamic to bring the hot sample into the coolest temperature of 3 degrees and then knock out the condensate. This is why it is so important over here, right? So, and I would like to pass it back to York. Is this okay? Should I continue from?
No. That's great. That's great. But I mean, remember the picture before. I think something we are not going to see from Gasmet in this session will be a cooler. And the reason why there is no cooler is the explanation, which they will give us. No, but Jemson, thank you very much for giving this overview. And I would like really to take this opportunity, because in other sessions we always talk about, okay, why is it there more than 300 different types of probes or variety of probes? And why do we have so many different heated sample lines? And Jemson, I really liked your sentence you said recently, that you said, okay, there's not just one standard SEMS, or not just one standard sampling system. So the sampling system always has to be adjusted on the requirements of the measurement, which is finally there. And therefore, I'm really happy to have these exotic components we are going to talk about from our experts in this session. So I think that really will give us a good overview. Just to finish this up, Jemson, if you go to the next slide, I mean, it's just an overview, the different types of probes. And I think this is something our guests will confirm, that the primary probe sampling, or the sampling probe, is very important. So if any component is lost due to different reasons, it could be the dew point, but it could also be that something
material selection.
So there's many specialities we have to consider, and very common, but also sometimes when we have to sample in ATEX conditions, there's even more special solutions needed. Something which unites us is the heated sample line. We always say in our session, it's one of the most underestimated items in the sample handling component. And I'm also excited to hear your opinion about that, dear guests. And I think that also shows we had a session here this year where we talked about surface and surface treatment, electropolishing, for example, siliconaire covering. So there's many ways, and also reflected into the heated sample lines and the heated sample line solutions. And then finally, we have this overview of the dryer, of the cooler, the gas cooler, where we offer different solutions there as well. And I think that's probably a pretty good point to hand over to our guests. Maybe to explain, why is a cooler, or would a cooler be a problem in your systems?
Yeah, for sure. We can we can talk about that one a little bit as
Yeah.
well. So we are basically working with hot wet technology. So
Right.
whatever comes from the stack, we are taking it as it is and keeping it hot all the way from the stack into our analyzer and analyzing it as hot. And of course,
But,
the benefit from that point of view is that we don't lose any components that are water soluble.
Okay, yeah, I think that's important to add. I think the reason is not that you don't want to use our great products, but
No, it's just that we are using a different technology, our technology, but we are using FDIR, so it requires this hot wet system. That's right.
no, absolutely. That means, to explain this, if you would need, if you would cool down the hot sample, nearly all the components, or the main components, would just be washed out, right?
Yeah, the water soluble components, that's correct.
Yeah.
And we want to analyze those ones. Those are actually the most important ones for our customers. So that's kind of the core of our technology, to measure those accurately.
Okay, very good. Yeah, Jürgi, you already started. Should I share your presentation? Is that a good?
Yeah, for sure. So thanks a lot. I was figuring that I could start by just giving a brief interview or a brief kind of introduction to Gasmet overall. But our main topic as of today will be continuous mercury monitoring, and then we have Steffi in the lab showing you a couple of systems live as well. So I think it should be a good combination for sure. All right. So I think most people already know Gasmet, but just to kind of give an overview, we only do gas analysis. That's really our specialty. So that's something that we have been doing for more than 30 years, and that's really what we're specialized in. And here, as of today, we're of course talking about emission monitoring, and that's really one of our top applications. But that's not actually the only applications. We are also present in environmental applications as well as safety applications. So if you, for example, want to know if there's something harmful in the air, that is something that we can figure out for you. So that's even our kind of a statement there. Know what's in the air. That's what we are. So we know what's in the air. And to kind of give you a couple of facts about us, so we are here in Finland. Both Steffi and I are here in the same office in Vantaa, so that's where our headquarters is. And then we also have a bunch of regional offices in Germany, the UK, Hong Kong, Canada, Austria. But actually, in most markets, we're acting through our distribution network. So in order to be as close to the customers as possible, we have distributors in more than 80 countries. So basically, wherever you are, we are very likely to have a distributor there that will be close to you, supporting you with all your questions. And like I said, it's more than 30 years that we have experience on this gas analysis, and really the technology that we started with, and what's one of our core technologies, is FDIR, so infrared spectroscopy with Fourier transform. That is in the core of our technology. And we're actually part of this Nederman group, which is specialized in clean air, with more than 2,000 employees. So we are part of that entity. And we do have a normal ISO certifications for quality and environmental control and so on. And all products actually that Steffi is showing today that I'm going to talk about, they're all handmade here in Finland in the same facility where we are.
Handmade in Finland is great.
Yeah.
I think that's great.
Absolutely.
That's great to read. That's great to read. Sorry, if you could just go back. Is there an explanation what the name Gasmet stands for? Like,
that's a good question. I haven't ever thought about. I was just thinking about, because we are measuring gases. It comes from that.
I don't want to be mean. I just want to I just want to hear if there's any, it's a well-established name in the in the industry.
Yeah. That's a good question. Have you, Steffi, heard about the history of our name?
No, to be honest, I haven't. Need to
No,
check that
well,
afterwards.
Yeah, but I think it's a good name because you can immediately understand what we're talking about. We're talking about measuring
Exactly.
gases.
But it's not that Matt, for example, is measuring in Finnish or something. That's not the case, no.
No,
And
no.
maybe
Not
it
such a
refers to
word.
like metrology, so measuring something.
Okay, all right. No,
That's what I've been thinking at least. I don't know if it's
no, that's all good. Jyrki, can you share how many installations of FDIR do you have? Is that a big number, a rough number, or?
Yeah, it's thousands and thousands, but do you, Steffi, remember the exact number? I mean, we're
Okay.
talking about thousands of systems, but
Yeah, it's
Wow.
thousands. I don't have a really specific record.
Okay, no.
I don't remember the
But
exact number
thousands.
either, but I'm thinking something in the range
Yeah.
of 5,000 at least.
Wow.
Yeah, something like that. Yeah.
Interesting. Yeah, okay. Thank you for giving this overview. Yeah.
Sure. And these are basically then the products that we use to go into these areas and measure gases. So we have basically two product families. We have emission monitoring systems. Those are the ones that I'm responsible of as a product manager. And then we have portable gas analyzers as well. So for the emission monitoring systems, we have three main products. We have FDIR for measuring multiple different gas components, including those ones we just talked about, those water-soluble ones. We have HCl, HF, ammonia, and so on and so on. Formaldehyde, for example, is something that we have certified. So these are this is the basic product that many customers need. But then we have a separate system for mercury monitoring, continuous mercury monitoring, as well as we have a separate product for long-term dioxin sampling. So I think the key here is that we work, for example, in waste incineration business, combustion plants, cement production, and so on. If you think about waste incineration, for example, what they will need to measure because of regulation, they will need to measure those components like HCl, HF, and so on. But also mercury they need to measure, and also they do need to sample dioxin. So what we are trying to provide here is really the full solution for these customers. Like a one-door solution, we can provide everything that they will need, also the dioxin sampling system.
Wow.
That is the idea with the emission monitoring side. And then the portable side is also actually quite interesting part that is special for us. So like I said, we have a very long history of this FDIR, and one of the most difficult things about FDIR is that it's relatively easy to make it as a stationary system, so it measures all right. But then to make it a portable system that still measures correctly after you take it to different customer sites, like for stack testing, for example, we have systems for that, or we have system for industrial hygiene applications where you measure what's in the air in different facilities, for example. So it's quite difficult actually to make it robust so that you can take it on site and still measure very accurately. And that is something that we have done. So we have these portable FDIR-based gas analyzers, both for ambient conditions and for hot vent environments as well. So they are up to the 180 degrees, like the normal FDIR. And the most typical applications I've also listed there. So stack testing is of course related to the emission monitoring system. So instead of having stationary system, if you are in a business that you have to go to several sites and measure from the stacks what is the concentration of certain gases, let's say formaldehyde, we have portable systems for that. But then also for these other solutions, so we have industrial hygiene, confined space monitoring. For example, if you have containers coming from big ships and you are not sure if there is some kind of hazardous gas in the air, you can use these analyzers to measure that. Okay. So it's pretty wide application scope that you have with these portable gas systems.
So it's, so to say, not just, this is something you mentioned in the introduction, it's not just emission monitoring, but it's safety also, safety-related issues, huh?
Yeah, exactly. So it's basically the emission monitoring, then we have safety, especially with these portable gas analyzers, and then also the, what it says, GHG, it means greenhouse gases. So it's actually also environmental research. And of course, this is one big topic of our time, the climate change and everything related to that. So of course, it's very nice that we can contribute to that by measuring different kinds of greenhouse gases coming from typically natural sources. So there are for researchers going into forests or swamps and measuring how different greenhouse gases are being released from the ground, for example.
Okay, right. Yeah.
So that's the kind of idea. This is the product portfolio we have. And of course, today we are more interested in the emission monitoring side. And of course, like I mentioned, the FDIR system, SEMS2, this is one of our main products. That is not the focus of the topic today, but just to mention that, yes, this is a hot-wet system for corrosive gases. So in this one, there is no cooler because of the FDIR technology. We want to have the hot-wet gas in. And the idea here is that this is a certified fully automatic multi-gas analysis system for all these components we already talked about. And really what's the special thing about our system is that what I would like to call is this is the smartest FDIR SEM solution, because first of all, it has very low cost of ownership. So the need for service is relatively low, and it's very easy to do the service. That's a specialty for us. And also flexibility is another thing. So in our case, it's actually quite flexible to meet customer specific requirements also later on. So if you are a waste incinerator, you need to measure certain components in certain accuracy. Then later on, you get new requirements from the authorities that now you have to measure a little bit different components, maybe, or a little bit different scales. Then we can actually change and configure your system very easily to accommodate those new limits. That is also special for us. And of course, like you mentioned earlier, I totally agree that sampling is a very important part of this system. So it's a hot-wet system, so everything needs to be kept very hot. No leakages. The most important thing is to ensure that we get the sample from the actual stack through the probe. There are a lot of selections, like you said, for different options of the probe and the sample line, through the sample line, to the sampling system, and into our analyzer. And once we get to our analyzer, then we know for sure that we are going to be extremely accurate. But we just have to be very careful to know that the sampling will be perfect.
Yeah, but I think it's great to read from a sampling point of view that optimized sampling is something you even highlight on your product overview. I think that also underlines the importance here, right?
Absolutely. So if we have, for example, a customer is asking for this system, we actually have a special department who looks into what are the components that we should use in that specific customer case. So it's very
right.
Sure.
Okay. Yeah, no, I think that's very interesting. Okay, yeah. So now just for our audience to understand, now we are moving from, let's say, the standard components, the standard gas components, and also the standard solution components like the probes and the heated lines, which we saw on the hot-wet system. We move to a different field, and like I said, I'm very excited to hear about the specialities of sampling of these type of components.
Yeah, for sure. Yeah, so like I said, we're going to focus on Mercury in a moment, but before that, we want to mention also about our dioxin collecting system. Like you said, it's a little bit more specialized than the FDIR. So in this case, the idea is that, for example, if you're a waste incinerator facility, you need to measure dioxins. And you do that with sampling. And you can do that with short-term sampling, or you can do that with long-term sampling. Now, what we are providing here is the long-term sampling solution for that. So our system is an automatic long-term dioxin sampling system, even for these kind of challenging conditions. And the idea here is that it's really very free system. So if you do periodic testing twice per year, it's kind of based on luck. What happens to be the dioxin content at that time when you're measuring, and you don't really know what's happening in your process. But if you're constantly sampling, you get a lot more data and a lot better idea how your process is changing over time, what are the dioxin concentrates, and really gives you that nice calm feeling, knowing that when the authorities come and ask you what are your dioxin concentrations, you know exactly what they are all the time. So in this system, we are using something we call the dilution sampling method, and this is really essential for high performance. So there is a small picture you can see on the right side there. So there is the flue gas, and we actually dilute that with instrument air in order to cool it down to make the dioxins get attached to the filter unit that we have actually in the probe. And that is a dry filter, and all the dioxins will be collected there. We usually measure for around a month. So we collect the dioxins in that filter, and after a month we change the filter, and the filter that we had, we send it to lab for further analysis. So they will analyze the actual dioxin.
Okay. So maybe very important to understand, this is not let's say, an online measurement, like we know this, or like we usually would do this, with the whole cold extractive analyzer system. So you are selecting, you are sampling and selecting the probe, and then it will be analyzed on a later stage, right?
That's correct, yes. So it's a long-term sampling system because of the chemicals and the process needed to extract from the dioxin. So there is no automatic online measurement system for dioxins available, but there are these long-term sampling systems that give you the long-term data. So maybe at this point, Steffi, if you're in the lab, you could show a little bit on the dioxin system.
Yeah, so let me open the cabinet.
Do the following. Yeah, that's great to see.
Yeah, so as you can see here, this is a cabinet and this is the sampling probe unit. So here on the cabinet, we have, of course, the terminal display where the software is running. And here is a printer that basically prints all the important values that the laboratory needs for the analysis. Of course, we also have the important information in electronic format as well, in case this ticket gets lost. Below, we have some volume measurement and humidity measurements that are performed, which the laboratory needs to be able to determine the dioxins in the sample. So here we have the sampling probe unit. So as Jyrki showed in the picture, the flue gas is sampled from the stack. This is a part in the stack and this is outside. And then it gets diluted with instrument air. And it's cooled down to around 40 degrees Celsius. And then the mixture of the dilution air and the flue gas passes through the filter where the dioxins are collected. So this is the filter unit, which is dismounted from the sampling probe unit and is sent to the laboratory. And then, of course, we send the customer an additional filter unit that needs to be mounted back to continue sampling as the already used one is taken for the analysis.
Okay, that means, Steffi, depending on the time of sampling, whenever one sampling period is over, you are going to change the filter and the selection of the probe, and then you're going to exchange it, right?
Exactly. And there are three layers of filters that capture the dioxins. And yeah, the remaining gas mixture passes through the heated sample line to the cabinet where the additional measurements take place, as I mentioned previously.
Okay.
So yeah, this is a great thing that we're using dilution, the dilution method, since we only get this dry filter, so it's dry sampling. We don't need to deal with any condensate, and it enables easy sample handling that we're using the instrument air for the sampling purposes.
Okay.
Yeah, and isn't it so that we're using isokinetic sample collection?
Yeah, we use isokinetic sampling, so it means that the velocity of the sample gas in stack is the same as the velocity of the sample gas taken through the nozzle of the sampling probe tube. And we are able to determine the isokinetic state by measuring the pressure difference in the nozzle. So if it's 0, it means that the sampling happens isokinetically. And we have two versions available, actually. We have the compact device, which is this one, and we have the standard device. And the main difference is that the compact device has this one probe tube in the sampling probe unit, whereas the standard device has two sampling probe tubes, and it is used for stacks with a very large diameter, let's say for over 2.5 meter diameter stacks.
Okay.
For a more representative sampling. Of course, it doesn't mean that the compact device cannot be used in purposes in like big stacks, but we can always look at each situation separately and try to find the best solution.
Okay. So,
for this.
Steffi, is there a standard length of the probe tube?
No, it's not. It depends on what the customer actually needs or what is the
So the
best.
customer could individualize. So you know the
Yeah,
dimension of the stack, and then you are going to recommend what length of the probe tube.
exactly.
Okay.
Exactly. It
Okay.
depends on each conditions. Yeah.
And the temperature of the probe, is it heated?
Yeah.
The-
If I remember, yeah, I think it's heated. I don't. Was it like 40 degrees Celsius? If I'm
Okay.
I'm not.
Okay.
Yeah, so in Dioxins, we don't need to be super hot from that point of view.
No, it's not
I
super
think
hot. Yeah.
from that point of view, so the special things are, for example, the pressure meters that you mentioned that are measuring the isokinetic, and those kind of things are special for the probe for sure. And of course, that this probe actually collects the information that we want, so it collects the actual dioxins in it. So then that is the kind of an end result what you have in the filters.
Okay. Okay. And just for my information, what is a typical time of sampling? Is it 1 week or 2 weeks?
It's actually 1 month. So 4 weeks is the typical sampling time, but it can be extended up to 6 weeks if necessary. But yeah, 4
Okay.
weeks is the typical sampling time.
Okay, so every once in a month, I have to go there, have to exchange the cartridge, and then it will
Yeah.
be analyzed later on.
Yeah,
Yeah.
exactly. So then when you look at your dioxin emissions, you have basically 12 points that are very representative because they each represent 1 month.
Yeah.
Instead of having 2 8-hour measurements per year, that doesn't really give you a picture of what's happening in the process. So that's really the difference that we have with the long-term sampling.
Okay, I understand. I understand. Okay, we have to look at the timing because
Yeah.
Yeah.
I'm so excited about the dioxide. So Steffi, I think you're going to move to another place, right? Or to
Yeah, I'm going to move to another place
okay,
where we have
okay.
the
Let me
Mercury.
just okay, but then Yaki, we can continue our discussion here. I think. Can you tell us? I mean, I realize it's different even in Europe. It's not that all waste incinerators have to measure or sample dioxin all the time. What is the situation there? Maybe you can explain us.
Yeah, that is correct. So it depends on the facility. So from the EU level, it is dictated that you have to measure dioxins. But in many countries, you can do that with a periodic monitoring of doing it twice per year. And then there are some countries where they might decide that all facilities need to do long-term sampling, or they might decide that if you have, let's say, one facility that is particularly close to a lot of inhabitation, a lot of houses, for example, then from that particular facility, you want to have continuous monitoring in order to make sure that your dioxin emissions won't go very high, because of course these are very toxic substances that we're talking about.
Right.
So again, it depends on the country a little bit what is required from the authority point of view. For all customers, what we're of course trying to always explain is that in order to control something, like they all want to control the dioxin emissions, you need to measure it, because otherwise it's going to be impossible to control it.
I understand. So what's your outlook? Do you think in the future we will see the dioxin measurement requirements from a legal point of view in all waste incinerators, or what do you think?
Well, you know about the regulations, so it's getting tighter and tighter all the time, and not only in Europe, but also in Asia, for example.
Sure.
So I think if we look forward, it will be probably mandatory to do more long-term sampling in different facilities for sure. So that is the direction where we're going. And it makes sense from that point of view that these dioxins, they are present in these processes of incineration. And they are very harmful. So from that point of view, it makes sense.
Okay, yeah, very, very interesting. Thank you for this outlook. I think Steffi already nearly arrived to her final destination. Maybe she
We can already talk about maybe the slides about the continuous monitoring.
Yeah, absolutely. Yeah, let's do this. Yeah.
But this is, for example, for sure one of the beef of the day, because I mean we are very much present in the mercury monitoring market, which is one of the things that you have to measure against. So yeah, I would like to have just a short introduction about the mercury monitoring regulation and needs. So of course, like you know, mercury, it's a long-range pollutant. So this is something that you don't want to get near to. And to the emission sources, there are of course natural sources like volcanic activity. But then the emission sources that we can control is the industrial processes like coal combustion, cement production, waste incineration. And because of these reasons, in Europe, for example, there is a document VIPREF that dictates that mercury actually needs to be monitored in waste incineration. And
Right.
what this document says, this regulation says, that is that you need to measure it continuously, unless there is one exception, unless you can prove that your mercury content is low and stable. And if you can prove that to the local authorities, then you can do also long-term sampling or periodic measurements. So
Okay.
this is the kind of regulatory background. So the continuous mercury monitoring is the default option. And you can see also the limits there. So this regulation comes in place at the end of 2023, so in 2 years. And the limit will be between 5 and 20 micrograms for daily average. So if you measure continuously, or then if you do sampling, then you have actually a little bit lower limits there. So again, this depends on the country. So in some countries, they might choose that they want to have a limit of 5 or 10. In some countries, they might decide that they want to have a limit of 20 micrograms. So that's what the range means. So the local authorities can decide on EU level.
Right.
So what's interesting about this is that, let's say that you're a waste incinerator. Typically what you're burning is not homogeneous. So you have very heterogeneous waste streams with varying mercury content. So this is an actual picture of what you can be actually incinerating in your process. So this is waste material coming from winter tires, for example, in here in Finland, where we use this kind of spike wheels. So you can really see that the waste they are burning it really varies a lot. And this also means that there is a large variance in the mercury concentration during the day and the week. So if you're a waste incinerator and you're thinking that, could I do periodic measurements or should I do continuous? You have to prove that your concentration of mercury is low all the time. And that might be very difficult or even impossible in many cases because of these waste streams varying so much. So actually I have some data here. This is an actual data from a waste incinerator where we have measured with our continuous mercury monitoring system the mercury emissions for 1 week. So you can see data for 7 days, each average for 1 hour. And there are several things we can see here. First of all, you can see some of the limits in the red and the green line. So if you want to do periodic measurements, you need to get external people, external authorities to check your dioxin levels. Now, if you do that check, if you happen to do that on day 1, very early in the morning, then you can see that your mercury limits and mercury emissions are quite low, so you can pass. But if you happen to have that same test on the same day, but in the afternoon, then you won't pass. Then you will be in issues because your mercury concentration will be actually a lot higher. So if you're relying on these periodic measurements, you have to be quite lucky in order to pass. And I'm sure this, if I would be a facility manager in some kind of waste incineration, this would really worry me because it's
Okay.
a random process.
Jürgen, that means the curves and the diagrams you showed there, you shared there, would look different when we talk about, for example, a coal power plant, right? So
Yeah,
depending
for sure.
on where the coal is from, there could be also a variety from whatever region it comes, especially in the specification of the mercury, but it wouldn't look, because I think that's always the argument that the waste incinerator companies, they don't know what kind of waste they get, right? So this is where the variety comes from, huh?
No, that is true. So if you're burning coal, you have a far better control of what you're actually burning. So then you have a better control of what will be your mercury emissions as well. So it's really the specialty of waste incinerator that the mercury content will be going up and down because you never know exactly what you're burning, like you said.
Yeah. Okay, I got it. Yeah, thanks.
And like you can see here, for example, if you compare day 2 and day 6, there's a very wide difference. So in day 2, the average is 24 micrograms, which is very high. And in day 6, you're talking about 9 micrograms, which is manageable. Yeah. So again, which day you happen to do your measurements, if you do periodic measurements, that will be very decisive.
I understand.
So that's why we always recommend continuous mercury monitoring, because that's the only way how you actually know what are your emissions, and you're not relying on your luck in a way. And of course, the other thing is that if you get this data, you only have this data if you measure continuously. Now you can see that, okay, I have these high peaks. Let's say on day 2, I have very high peak in the morning, very high peak in the evening. So then I can go back to look what happened in my process. So what kind of waste was I burning at that time? And then you can do something about it. You can actually fix it when you have measured it.
I understand. Okay. Yeah, and I think the special thing is with this, because I mean, what are we doing with SEMS measurement? It's we register how much emissions were actually emitted, but my understanding is also that you use this real-time data in order to control the mercury reduction activities or measurements in the plants. Is this the case, right?
Absolutely. So that's the next step. So of course, the first step is that you have regulation you need to pass. You need to be within the limits. But the second step is that then you can actually control what you do in the process, like you mentioned. So there are techniques that you use to reduce the amount of mercury, and you can optimize it when you notice it.
By the way, Jensen, is in Asia, what is the situation there regarding mercury? Are you guys in your region? Is it mandatory to measure mercury?
Yeah, I think at this point of time, Indonesia surprisingly is leading and is taking mercury requirement in most of the coal-fired power plant.
Okay.
And it's mandatory now. At this point of time.
Okay, but the focus at the moment in your region, let's say, is more the area of power plants, and I mean that's probably something very similar in our history, but then it shifted to waste incinerators, right? Okay, got it. Yeah, let's. I think we have to a little bit keep an eye on the timing.
Sure. Yeah, let's go forward so that we have time to actually look at the system. And I mean, that's what we want to do for sure. So what's our solution for measuring is our CMM, so continuous mercury monitoring system, and this is of course also a hot wet system. So we are not we are using it in the exact same conditions as the FDIR. And this is really the benchmark system in the market. So it has the lowest certified measurement range. Like with the same system with the FDIR, very easy to operate and low cost of ownership. And one special thing is actually related to minimize downtime and maintenance costs using automatic Cal3 function that I will mention in a couple of slides. Right. So these are the different system parts. So of course we have the probe, which is in this case dilution probe. We have a heated sample line, heated to at least 180 degrees. We have the cabinet, the analyzer, and then we have test gas generator that creates test gases that we require in these tests. So if we, for example, look at the probe, the special thing about mercury, it comes in two formats. It comes in elementary and ionized format. And this is a difficult gas actually to monitor, because these gases, they really like to adhere to your sampling system. So you need to really have a really careful look in how to minimize that adsorption onto your surfaces. And of course, the probe is a very important part of it. What we do here is we use dilution method, where we dilute the gas with a ratio of 1 to 50. And we do this to get a lot faster response times, as well as to reduce any interferences from other gases, because of course there are other gases in the gas matrix as well at the same time. So this is very important for us. On the other hand, the probe tube that is heated, so we need to keep everything very much heated, as well as the probe as well. But in addition to this, we have a very special proprietary glass coating on the stainless steel probe, and also the filter that you can see here in the image. So without this coating, you will get adhered material from the mercury. So you can see actually the picture of the filter here. So it's a special probe. In many cases, we're talking about that the bigger the probe, the better in FDIR in many cases. In this case, it's actually a little bit the opposite. The smaller the probe, smaller the filter, the better, because it's easier to control the cleanliness of this filter. And we do that with a two-stage blowback system. So automatically the system, typically, let's say once a day, you have a blowback that is two-phase. The first phase is that it releases the dust from the filter, And the second phase is that it blows the dust away from the probe tube back into the stack. So it's two phases.
Jamson, have you heard that? That's nearly the same. It's exactly same concept like our back purging or PSG Plus with the dual stage back purging. It's nice to hear that. But also interesting to mention the difference, like you said, big surface filter is something which is an advantage in other measurements, but in this measurements, like you said, if you offer more surface for the mercury to stick on, it's going to cause more problems, right? So fast response times is T90 time reduction. That's interesting to see. Okay, thanks for sharing.
Absolutely, and usually you want to have a big filter so that you don't have to change it that often. But in this case, actually, even though we have a tiny filter, this might even last for years depending on the facility. So it's a very long lifetime filter, partially because of the blowback.
Okay.
Another thing, of course, the sampling line is also, I would say, a little bit more specialized than what we have in FDIR. So also here in our sample line, we have the same proprietary glass coating to prevent adsorption and desorption. So again, if this is missing, then you're going to have a hard time in getting all that mercury through your sampling system and into the analyzer. Of course, this is heated also to prevent all that condensation you talked about. And it's a special structure because we have actually a lot of going on in this line. So we have the sample gas, but we also have the blowback gas. We have the span gases going from the cabinet into the probe. So we feed the span gases through the whole system to test that it works. And then, of course, all the power and signal cables. So this is really a specialized sample line that has been optimized for a long time. So it's actually quite difficult to make this right.
Yeah. So would you for the blowback, would you bring the heated? Is it heated blowback or is it preheated? The instrument air?
Yeah, it goes into the same sample line, insulated as well. So yes,
it is.
So
you heat it.
Yeah, we don't want to cool down the system, the probe too much. So if we cool it down too much, then we're going to have issues with condensation.
Yeah. It's very crucial part. PSG Hybrid is our extruded heated sample line product for solutions like this. Yeah.
Yeah, exactly. So it's a very special system. And then of course, when we get everything through, then it goes to the Mercury Analyzer. And then we are good to go because we have the lowest certified range in the world. So it's the most accurate system in the world. So it uses the cold vapor atomic fluorescence method, CVAF. And there is a thermal converter. So like I mentioned, there is ionic mercury and there is elemental mercury. So we have to change all of that before the analysis into elementary mercury. And we do that with a thermal converter, which is just before the sample cell. So there is no recombination after that. So that's what we analyze. We analyze the elementary. And then there is the automatic daily check and adjustment with elemental mercury. And actually in this analyzer itself, there is an integrated touch display that Steffi will show in just a moment with software we call MAUI. And that controls all the functions. And the final thing I want to say before we let Steffi show the system in real life is a little bit related to the quality assurance level. So in Europe, in order to use these systems in regulated environment, there are 3 levels: GAL1, GAL2, GAL3. GAL1 means that we, as a manufacturer, we will certify the system that it works as it should. Then GAL2 means that, okay, now you invest in the system, we go to site, we install it. Then there is an external party, like competent authority, that comes and calibrates the system against a standard reference model. But then during the use,
and there's an interesting. We have a question about that. There's someone asking, could you detail the automatic QLL3 procedure on your system? Maybe you could just keep it in mind in your answers.
Absolutely. So that's a good question. So the GAL3, it means the performance checks that need to be done by the user, and typically at least 4 times per year. So you have to do it multiple times per year. And the typical way how you do this test for a Mercury Analyzer system is you have an external supply or external generator that creates this mercury chloride. And you create that gas with that external supply and you pump it through the whole system and you see if it measures correctly or not. That is the typical way. So you purchase somebody from outside as a service to come to your site with that pump, do the measurement and check if it works. I mean, our idea is that, and this is something that we are actually quite proud of, is that we have an option we call Autocal that you can get for the CMM. And in this case, we basically, instead of getting the external person to our site with the external test gas generator, we actually have a similar idea, similar test gas generator integrated already into our system and certified. And because it's integrated into the system, we can simply tell in the MAUI software that we want to do this GAL3 test whenever we want. Usually we do it, let's say, once per week. And it automatically runs that without anybody having to go to the actual site, so no external part is required. And the full system is tested, so it creates this test gas and it puts it to the probe, to the sample line, to the converter, to the analyzer. So we make sure that the full system works, not just the analyzer, but the full system.
Great.
And it's all programmable.
Okay, now I think we have 5 minutes left. I think we should move over to Steffi so that she can really show us in detail and in real life the solution. I think that would be interesting to see.
Yeah,
Sorry.
sure. Yeah, so this is the system, CMM Autocal. Here, as you can see, we have the CVAF analyzer where the software is running, and below we have the test gas generator for the mercury chloride and the elemental mercury. And here are some pressure regulators for the system pressure and the test gas generator adjustments. And below here we have the nitrogen generator, which is used for the dilution of the sample, and it's generated from instrument air. And yeah, if we take a look at the probe real fast.
Yeah.
So as you can see, well, here is actually the probe tube or the sampling probe unit. Here's the probe tube, and
this is not this is the oh, it's just two systems, right? So it's
yeah, yeah, exactly. It's basically the same system, but
okay,
yeah.
Got it. Yeah.
So here we have the inside parts of the sampling probe unit. So the two-stage blowback happens so that the first blow happens from this side, and then the second blow happens from this side in order to evacuate the loosened dust out of the probe tube.
Okay.
So this is just the pressure tank used for the blowback.
Okay. Okay, an accumulator, so to say, that there is an efficient blowback possible, right?
Yeah, exactly.
Mm-hmm.
Yeah, that's the case. And well, someone asked about the thermal converter, about the temperature. It's 700 degrees Celsius.
Okay, yeah. Yeah,
quite
you saw
hot.
The question, right?
Yeah, and just a quick look at the software. So here is the software. We can see basically the Mercury trend view here. It updates every 1 minute. We can see the total value of the mercury, total mercury, and the customer can perform different actions, can set all the timings for the calibrations. So it doesn't require much, just setting the intervals and times, and the system basically does everything else. And you're able to see some important values. You are able to see all the alarms, what basically causes a certain alarm to be activated, and you can easily also.
Steffi, also from a sampling point of view, are you guys measuring and recording all the important figures like the temperature of the probe and temperature of heated line and kind of a condition?
Yes, everything is monitored. Yes, yes, that's correct.
Yeah.
Of course, it's important to check all this.
Yeah.
And yeah, from here you can just see easily if the tests Cal3 checks and 0 checks have passed. So basically the calibrations. So it's easy to check from there if there is an issue. And yeah, it's a quite easy software.
Okay, great.
Yeah, so that's a quick overview of the device.
Thank you. Thank you so much. Thank you so much for giving us this overview and seeing this. Okay, so as I said, it's always hard to believe. We have 1 hour and we think, wow, it's so much time, but it's not. We are already at the end of our session here. Yeah, I mean, that's sure in 1 hour to give an overview of the company, to give an overview of the different components, and we talked about dioxin and mercury and your FDIR solution. So it's not possible to go into this in very detail, but I think it was impressive to see, also the reflection, and even maybe it's more crucial, the components we've been discussing here, the reflection of the sample handling components to the complete analyzer system. So allow me to thank you for being our guest today.
Thank you.
I hope we see us next week in our Christmas party. And I must say it was a very interesting session, and I really want to thank you for this. And we are going to answer, the audience, we are going to answer your open questions in the chat. We will make sure that nothing remains unanswered. Okay? All right.
Yeah.
Take care, everyone.
Thank you so much.
Thank you so much.
Thank
Yeah.
you.
Guys, right? Bye-bye.
Yes.
Yeah.
Bye.
Bye-bye.
Bye-bye.